Okay, so I just want to continue this set of slides that I started into the last day with you. Right, so just a quick summary. We talked the last day about this notion of component state. And a state is nothing other than a variable that's internal to a component. But what's significant about it is if that state variable changes its value, then the component re-renders or re-executes itself. The way we declare a state variable is slightly special, and also the way we mutate or change a state variable is special as well. Then I talked about data flow within a React app, and data flow we said was unidirectional, could only flow from parent to child components. And I also, as I talked my way through the diagram, which is this diagram here, I talked about the significance of, well, the difference between stateful and stateless components. And also when a stateful component, i.e. a component that has some internal state variables, when that component's state changes, obviously the component re-renders, but also automatically its children re-render. And equally, when a stateless component re-renders, its children re-render. So you got this kind of ripple effect right down the hierarchy. Can I just confirm that people can hear me at this stage?
Yeah.
Great. Okay, so the next topic then I started digging into was this notion of hooks associated with React. And hooks are they're functions, number one, but they're all about, these functions are all about controlling a component state and also manipulating a component's life cycle. And there were special rules then as to where you could, so these hooks are just functions, as we said, provided by the React framework. And you could only call these functions, these hook functions, from the base of a component implementation itself. What I said was it could only be invoked from the top level. So we had all that anyway the last day. And in fact, the use state was the first hook that we saw. The second hook that I wanted to mention to you is the use effect hook. This is kind of where I left off the last day. And you would use the use effect hook if you wanted a component to create, to have a side effect. And a side effect is where a component either tries to access something outside of its scope or potentially change something outside of its scope. That's what this notion of a side effect is all about. It's a general programming thing. The most common usage of the use effect hook is when a component wants to talk to a web API. And that's the one that we'll predominantly use it for. But I gave you another example here then as well about if a component wants to subscribe, as we say, to a browser event, and every time that browser event occurs, you want to execute a particular piece of code within your component. So the use effect is a hook, which means it's a function. This is the signature of the function. It expects 2 arguments. The callback is a function. And the callback contains the side effect code that you want to have executed. The dependency array, I'll just leave that there just for a minute. What its significance is. This use effect hook, when is it executed? Number one, it's always executed when a component is mounted. I used this kind of verb mounting and unmounting the last day, and it was in the context of that component hierarchy. And what I said back then was that as the user interacts with a React app that's currently running in the browser, it's quite possible that certain components within the hierarchy become active and inactive. And if they become inactive, they are kind of temporarily detached from the hierarchy. And if they are detached from the hierarchy, then they're not contributing anything to what's being displayed on the screen. When they're reattached onto the hierarchy, then they start to contribute something to what's being displayed. And this detaching and reattaching, or more properly, mounting and unmounting, goes on, can happen many times when a React app is running in the browser. So back to use effect. When a component, if a component is using this use effect hook, then the use effect hook will always be executed when that component is mounted onto the hierarchy or remounted. And by that, I mean, the callback is actually executed. The second instance then when it would potentially execute is related back to this dependency array. The dependency array is going to be an array of variable references. Typically, it refers to state variables within that component. It doesn't have to, but typically it does. And what I'm saying down here is if a component re-renders and that component has a use effect hook, what React will do is it will check the variables that are mentioned in the dependency array of that use effect hook, and it will determine have they changed since the previous re-rendering. And if they have, then it will execute the use effect hook. If they haven't, it'll leave it alone. So just to clarify now, so the question is, when does the use effect callback get executed? Number one, it will always be executed when the component is mounted or reattached to the hierarchy. And once it is reattached, it's possible that that component re-renders many times, maybe because it has a state variable that changes or its parent forced it to re-render. So it'll be re-rendering many times. But the use effect hook within that component that's re-rendering many times, it will only execute on a re-rendering if one of the variables within its dependency array has changed since the immediately preceding re-rendering. Hence the kind of name dependency array, that the callback, its execution is somehow dependent on what's happening within the variables in this array. Quite often, all you want is the use effect hook to execute on mounting and never again. You don't want it executing every time the component re-renders. If that's the case, then what you do is you give an empty dependency array, and we'll see that as well. So it's important that you understand now when the use effect gets executed. Let's look at a little sample application. Now you'll get this sample application with this archive. So if you download it and unzip it, then what you will get is you'll get a folder like this. And if we go into it, we have two sample apps. So we're looking at sample app 1 right now. So if I just import that into VS Code, so it's an app that I created using the Create React App tool. So I'll just start it up just show you it running. So what it does is it makes an API call to the random user web API that we came across there a few weeks back. And it asks it for, in this case, I think 10 profiles. So these are Maria, 10 of my friends. And if I stop typing into the text box, it will filter this list of friends based on their kind of, I'm not sure if it's their surname or their full name, but either way, it'll filter them. So if I go, anybody with R, yeah, okay, and you can type as many characters as you want to. So that's what the app does. Now, I'm actually giving you the component hierarchy for this app. And for now, just don't worry about, well, how did I come up with this component hierarchy? We'll deal with that in another lecture. So this is the hierarchy. And you can see from my kind of color coding, the component at the top of the hierarchy is a stateful one. These two components are stateless. And in terms of what the components actually contribute to the UI, I'm kind of giving you a hint here. This component is responsible for rendering one friend. Obviously, at runtime, there would be many instances of this component generated to generate each of the friend instances. This component is essentially responsible for managing the list of friends. And this component, it displays the header, it displays the text box and manages the text box. And obviously, it kind of delegates to this component as well. So this is the one that we're kind of really interested in because it's stateful. And I'm saying at the bottom left of the screen here that the state variables that are contained within this component, there are two state variables. One is going to hold the full list of friends that have been returned by the Web API. And the second state variable is going to store the current contents of the text box. Again, don't worry about, well, how did I come up with that decision? All we're interested in now is understanding how the kind of app works. We don't need to worry about how we came up with all these design decisions. Okay, so this is the only interesting component really. So maybe if we just quickly look at the code, and I kind of take it from the bottom up. I'll show you the less interesting components first. So here's the friend component. And it's fairly uninteresting, right? What it receives a prop, which is essentially just an object that contains the friend's name and details, and I'm just displaying them. I have a console.log in here, which will become useful later on, but for now, that's all that component does. So as I said, it's fairly uninteresting. Here's the filtered friends list component. This is the one in the middle of my hierarchy. That also receives a prop, and the prop is an array of friend objects. And you can see what I'm doing here. I'm mapping over that array that has been passed in to me and just and rendering it here. So again, there's nothing interesting there. This then is the component at the top of the hierarchy. So let's take it from the top down. So it has, first of all, we can see it has two state variables. As I mentioned, this state variable is going to be the one that stores what's in the text box. This is the state variable. It's going to store the full list of friends returned by the Web API. And I've initialized this to an empty array, as you'll see here. And I've initialized this to an empty string, which makes sense as well. Here's my use effect hook. And again, I've got a console.log that'll be useful later on, but within the use effect hook, the callback essentially that I'm passing to it is this entire piece of code here. And here we go again, making a fetch call, which we're kind of familiar with. So I don't need to explain that, but this line is significant. So this line is going to execute when the Web API, the random user Web API response comes back. And of course, when that array of users or array of friends comes back, I need to change my state variable up here. And that indeed is what I'm doing. Here's my dependency array for my use effect, and it's an empty array. So I'm essentially saying I only want this code to execute when the component mounts, which is really when the app runs initially in the browser. Other than that, this is just like the event handler associated with the user typing something into the text box. So when they type a character into the text box, this executes. Of course, one thing that I want to do is to change my state variable that's holding on to the current contents of the text box, because whenever the user types something into the text box, we do need to recompute the list of matching friends. Here's where I'm computing my list of matching friends. Okay, friends refers to my state variable, and I'm just filtering over it. So this here needs to execute, essentially, this needs to execute every time the component re-renders. In other words, every time there is a state variable change, this is always going to execute, which makes sense. But all it's doing is it's filtering over my full list of friends. And here here's my text box. And here I'm calling the filtered friends component, passing down the list of matching friends that has been computed up here. So when I load my app into the browser, this entire component is going to mount. And what's going to happen? Well, the use effect is going to run, because I said use effect always runs at mount time. Now, of course, it's making an API call, so we won't get the data immediately. It'll come sometime later on. What's also going to execute on the initial mounting is this. It needs to compute the list of matching friends. Now, I did set my friends state variable. I initialized it to the empty array. So this is still going to work okay, even though we're filtering an empty array, which means it returns an empty array. And it's going to render this. And so it's going to pass down to this component. It's going to pass down an empty array, which is fine. And we saw that component, it maps over the empty array. So it's essentially not going to generate any friends. In the meantime, though, the fetch responds back. So we now have a full list of friends, and we change the state variable that's holding on to the list of friends. Changing the state variable means the component is going to re-render all over again. And the significant part about the re-rendering is this is going to happen all over again. It's going to recompute my list of matching friends. Now my text box is empty, so this list is going to be the full list of friends. That's what I pass down to this component. And voila, my full list of friends are displayed on the screen. The use effect hook has not executed now at all this time. This is the second rendering of this component. The use effect hasn't executed because I've told it that the use effect hook doesn't really depend on anything changing. Later on, the user types something into the text box. That triggers this piece of code because that handles that. That makes a state change as a result of that line there. That means the component re-renders all over again. The use effect is not going to execute this time. This is going to execute, but of course now the state variable that's holding on to the contents of the text box has changed. So it is going to compute, the filtering is going to compute a subset of my full list of friends based on the kind of code that I have in here. Okay, so that's a talk through how it works. The one thing that's not obvious from my kind of talk through or walk through the code there is what I'm stating here, which is maybe not that significant for this app, but it could be for other apps. Now, what I'm saying is that the use effect runs at the end of a component's mount process. Okay, it always runs at the end. Now, you might think, if I just flip over back again to the code, if you think about the first rendering of this component, then you would say, well, obviously, these lines execute first, then this executes. Okay, the fetch makes an API call, but at least the first thing we'd expect to see coming out on the console is that. Then this executes. Then, well, sorry, this doesn't execute, that's just an assignment statement. This executes. Then this console.log happens, and then this stuff happens. So in terms of the console.logs, we would expect this console.log to appear first in the dev tools and this one to appear second. But in fact, that's not what happens, because when a component has a use effect hook, the use effect hook will execute after the component has mounted. And I can kind of prove that. So what I'm showing you here in the screenshot is I've opened up my developer tools and I've just ran the app in the browser. I haven't typed anything into the text box now initially. Okay. So what I'm seeing here from the console.logs is confirming kind of what I'm stating up here, because this console.log came from, sorry now for flicking around, but this came from this console.log down here, even though the other console.log is ahead of it physically in the code. This one actually appears first. Then we get the console.log that's associated with the use effect hook. Why did this happen? Well, the use effect hook made an API call to the web API. Eventually, it responded back with a list of friends. And as you saw in my use effect code, I changed the state variable that's managing the full list of friends. That's a state variable change, which means my component re-renders. And that's why the second console.log in my code is appearing again. Is the same kind of console.log statement that's running 2 times, and because my component has rendered twice. Eventually then I type something into the text box. Type something into the text box, as we saw from the code, causes my component at the top of the hierarchy to make a state change, and therefore the component re-renders, which is why this console.log statement appears again. Note, we don't see the console.log associated with this because we do not want our use effect hook. We only want it to execute at mount time. We don't want to execute it subsequently. So that's explaining the kind of the various re-renderings that are happening. But the key point that I want to get across here is the fact that the use effect for the very first rendering of my component at the top of the hierarchy, the use effect hook executes at the end of the mount process. It doesn't execute in the order in which it appears in the component's actual code. Don't know if you have any questions or not. Obviously, you need to play around with this application in your own time now. So I'll move on, sticking with the same sample app though. What else do we want to know about? Okay, I'm saying here that I guess you need to be aware of what I've just mentioned on the previous slide, in that the data from the API obviously is not going to be available to us for the very first rendering of our component. In other words, if I go back, our component has rendered once now already, but we don't have any users. So you've got to be aware of that. And you've got to ensure that your app will still work. It won't kind of crash essentially. And so what it means in this case anyway is that you've got to make sure that you initialize the state variable that's holding on to, that's storing the full list of friends, initialize it sensibly. And sensibly in this case would be initialize it to an empty array. If I kind of initialize it to null, then that's actually going to cause my application to crash. And it's going to crash because on the very first rendering, when it gets to execute, this here, what we're trying to invoke is we're trying to invoke the filter method on a null variable. And that's just going to throw up this exception. In fact, if I just prove it to you, if I change this to null, you might think it's not significant what we initialize it to, because eventually it's going to have an array of users. But if I do initialize it to null, and save it and go back to here, then there's my error. And this is actually the error that I mentioned to you way back that everybody kind of gets eventually. I'm trying to access, well, it's not referring to undefined in this case, but it's kind of telling you, look, you're trying to invoke filter on a null variable, and that's doesn't evaluate properly. We're going to do that. Now, like so in the previous, if I go back to here, right, I'm only showing you here the various re-renderings that are happening to my component at the top of the hierarchy, the stateful ones. But you see, in fact, because that component has children and grandchildren, if you like, all of those ones are re-rendering and rendering and re-rendering as well. And that's what I'm proving from this screenshot. So in order for you to simulate this, what you will have to do, obviously, I guess, is to go into the other two components and just re-enable the console log statements that I have in them there and there. So I did that, and then I ran my application. And I'm showing you here the kind of the screenshot from the screenshot, exactly all the renderings and re-renderings that happened. Now, it's hard to kind of talk my way through it. You really have to play around with it yourself, but I'll just have one go at it. We've seen this already, right? Well, essentially we have anyway. So the component at the top of the hierarchy, that renders initially. We don't have any data so far. We don't have any data. We've got an empty array, but the filtered friends component, that's the second one, the middle one in the hierarchy, that does receive an empty array. So it goes through its rendering process. Now it doesn't generate any friend component instances. So that's all right. My fetch executes. Eventually it comes back with data, changes the state, variable, the associated state variable. So the component at the top of the hierarchy renders all over again. It now has, I think I set it so that I only got 6 friends from the API so that I could fit it onto one screen. So on this secondary rendering of the stateful component, the one at the top of the hierarchy, it now essentially passes all of the 6 friends down to the middle component. And that then generates 6 instances of the friend component. So, and each of them go through their own rendering process. Then I'm saying, suppose the user types a particular character into the text box. That causes a state change in the top component, so it re-renders. It also recomputes my list of matching friends. It passes that new list of matching friends down to the middle component, and the middle component generates causes the re-rendering of the particular friends that had the matching name. So the components, the friend components here that are not included here, we would say that those friend component instances unmount from the hierarchy. Hence, they don't go through a rendering process, and I can't prove it over here, but obviously they disappear from the list. The user types something else, another character into the text box. You kind of get the same sequence again. Component at the top re-renders, it computes a smaller subset of matching friends, passes that down to its subordinate component. It goes through a rendering process. And at this stage now, there's only two friends components that go through their re-rendering. But so some of the ones up here did not go through a re-rendering. In fact, they were detached temporarily or unmounted from the component hierarchy. So that's again, a nice illustration of both unidirectional data flow and also the various re-renderings that are happening. And as well, this idea of components mounting and unmounting. We don't have any remounting. I guess if you see over here, I type 2 characters into the text box. If I hit delete, then that means we're kind of back to this situation. And what you would see down here is you would see friends that appeared here and didn't appear here. Sorry, friends that appeared here and didn't appear here. They would be remounted or reattached onto the hierarchy. So it gets complicated when you start entering state or dynamics, but so it is really important, I think, that you go back and you play around with this simple app yourself and make sure you're comfortable with this kind of whole thing about re-rendering and also the role of the use effect hook. Now I've kept it simple in terms of the use effect hook in that it only executes once, doesn't need to re-execute again. In another sample app that I'll show you, we have a use effect hook that executes more than once. Obviously complicates the situation, but the principles are the same. Again, I'll just pause for a second if people have any questions. Okay, the more to come is right now, actually. So I need to go into the second set of slides now. So I'm going to exit out of these, I guess. I'm going to continue on by looking at this set of slides here. And it's going to be the same theme, really, which is kind of this use effect hook and data flow as well. Yikes, I don't want that. So a little bit more on the use effect hook and the whole notion of component lifecycle, because as I said there a moment ago, we kept it simple in that our use effect hook only executed at mount time and it never re-executed again. And it also turns out that there are two data flow patterns in React. The one that we've been looking at is the unidirectional data flow. There's this other one as well called data down, action up, which is one that we will also see quite a lot. So let's deal with the virtual DOM. The virtual DOM is something that I'm just going to mention. It's a central piece of React's internal workings. You just need to be aware of it, but you don't necessarily need to. You'll never interact with it directly, but it's a critical piece of the how React actually carries out updates to the browser's DOM. But I'll leave that until the end. So what I've decided to do, not purposefully, but to complicate things, is the following. I'm sticking with the same sample app that we're looking at, but I've added in two features. One is I have a reset button, and the idea is when the user clicks the reset button, I want to grab 10 more friends from the web API. Now, I don't add the friends to the current list, not for any particular reason. I just simply overwrite the previous set of friends that I got from the web API, but I am changing. So the net effect is I'm two things. I'm making a new API call, and I'm overwriting the state variable that's holding on to the list of friends. And secondly, I want my app to type or to display in the browser's tab the number of matching friends that are being displayed down here. So clearly this is another example of a side effect. We want to write to the browser's tab. So there are the two kind of user features. Just bear with me 1 second now, sorry. Okay, now in terms of my app architecture, it's the exact same as before, but there's an additional state variable that again is going to be managed by this component. So it now has 3 state variables, and the new state variable is the one that's going to record the fact that the user has clicked the reset button, because clicking that button, needs to trigger certain actions on the part of our component. Now, I decided to implement this third state variable just as a Boolean, and it'll just toggle from true to false, true to false all the time back, so every time it changes, whether it changes from true to false or false to true, when that change happens, my app needs to make a new API call. In other words, the particular use effect is going to have to execute for each of those events, if you like. In terms of side effects, I've kind of already alluded to it. Our app is going to have 2 side effects now. This is the one we've already had. The new side effect is going to be the one that's going to take care of writing to the browser's tab. Okay, so obviously there's just more complications and added into the app. Now, in order to get, just give me 1 second now, sorry. No, I won't do that. In order to run this second version of the app, what you do is, you'll see here, I've got an app.js and an app2.js. So app2.js now is the new stateful component at the top of the hierarchy. And what you have to do, I think, is you've got to go into the index.js and just change this to refer to app2. And save that. So in terms of the workings, every time I click this, you can see it's getting a new list of friends every time. This works the same as before. And hopefully you can see over here on the right, it's displaying the number of matching friends. So it's 10 initially, but obviously if I change it to W, no. Okay, it's computed subset, and also my browser tab has changed as well. So that's just the user experience, if you like. And the only thing that's different, obviously, is app 2 versus the previous app. So if I just kind of glance at app 2, it's just more code, but it's more of the same code. Here are my 3 state variables. This is the new one. I've initialized it just arbitrarily to true. Doesn't matter whether I initialize it to true or to false. I did decide to use a Boolean. I could have used an integer and initialize it to 0. And then every time the user clicks the button, just increment that by 1. That would work as well, but a Boolean works fine for this case. So that's my new state variable. Here's the use effect that makes the API call, but notice what I have here now. I have my dependency array. And I'm saying anytime the reset, this guy here, anytime that changes, then re-execute this callback. And we'll see in a second what would cause that to change, but this is a good example now of a dependency array. And it is a state variable that is linked to. This is the same as before. This is the same as before. And sorry, yeah, okay. Here's the second use effect. This is the one that's writing to the browser's tab. Now, you wouldn't know this obviously, but that's how we write to the browser's tab. And what we're writing is, we're constructing a string where we're computing the length of my list of matching friends, which is being computed here. But okay, so that's that. Sorry. In terms of its dependency array, this is kind of interesting. The dependency array I'm saying is whatever the length of the list of matching friends is. If that changes, then this second effect should execute. And that kind of makes sense because what we want to write into the browser tab is the number of matching friends. And well, I guess that just this makes sense as a dependency array entry. Just if the length, sorry, when this component re-renders, if the length of the list of matching friends has changed, and that is, it's recomputed every time the component re-renders. If the length of it changes, then update the browser tab essentially. And the only thing new down the JSX is my button, and it has an event handler. Now I've actually buried the event handler code itself within the button JSX. You can do that if the event handler is kind of a one-liner, which it is in this case. If you wanted to, you could just grab this arrow function and declare it up here somewhere, and then just refer to it. But as I said, because it's a one-liner, you can actually do what I'm doing here. And you can see what the event handler is doing. It's changing the reset variable, and it's essentially taking the current value of the reset variable, which is our Boolean, and it's reversing its sense. It's changing from true to false or false to true, but it is causing the state change anyway. So what I did then was, on this slide here, I'm showing you the rendering and re-rendering only of the top component now in my hierarchy, how it actually re-renders lots of times. And also I'm showing you when the use effect hooks actually execute. I'm not bothering with the lower components in the hierarchy now. They would just complicate the picture unnecessarily. And so again, if you'll allow me, if I just step through it, and then we'll leave it at that. So I load the app into the browser. And so obviously my component at the top renders. Then the two, as we know, the two use effects run. And we know that the use effect hooks always run after the component has mounted for the first time. So these two run. This one makes the API call. This one writes to the browser tab. So it's actually going to write 0 matches because my list of matching friends is going to be 0. This happened here because eventually the API came back with the response. So we now have our full 10 friends, let's say. And it computes the list of matching friends, which also happens to be 10. That means the use effect that writes to the browser tab needs to execute because its dependency array said if the size of the matching friends array changes, and will have when the component re-rendered and recomputed. So it executes again, that use effect executes again and updates the browser tab. Then let's supposing the user types something into the text box. That causes my stateful component to re-render yet again. It's going to compute the list of matching friends. So that list is going to be smaller than what it was up here, which means that this use effect that writes to the browser tab executes again because its dependency array stated that it should. Let's supposing the user now hits the reset button. That hitting the reset button changes the state variable in my component. It re-renders yet again. The use effect that makes the API call runs this time because that use effect, its dependency array referenced the state variable that has changed. So it makes another API call. Eventually, the API response comes back. And we update the state variable that holds the list of matching friends, which is why my component renders yet again. It's also going to compute the list of matching friends, which is now gone back up to 10. And that means this side effect, use effect, is going to execute. So you have all the different scenarios there. And really, I don't expect you to immediately, I think anyway, understand this flow. You really need to play with the app, and I would strongly recommend it because this is kind of as simple as it will get in terms of use effect and use state. And you know what? Well, what's going to increase in complexity is more the number of components in your hierarchy. And we just have 3 components in our hierarchy there. And that's pretty much as simple as I could make it. So if you go back and study this app, both version 1 and version 2, and play around with it, and you're happy that you understand, you know, what I'm illustrating here, and you can rationalize it for yourselves, then you're in a good place really from here on in. And I'm just documenting here really like what happens when the component at the top of the hierarchy, when that mounts, all of these things happen. And the previous slide kind of confirmed that. What happens when the user types something into the text box? In terms of state changes and particular use effect hooks running or not, I'm stating here what happens. And thirdly, then, what happens when the user clicks the reset button? Right, so it's heavy going, but I guess it's an appropriate point to stall it for today. So I'll pick up the story the next day from this point on.